So I know what y'all are thinking after seeing that beautiful intro clip. Wow. Now this guy is a genius. And he really knows everything there is to know about shader code. Nope. Just my opinion. The thing I want to talk about today is something called slang. So, what is slang? Slang, to my understanding, is basically a compiler. You would run the slang C on a .slang file, and you would compile it to GLSL, HLSL, WebGL, MGL, whatever you want. Alright, so with all of that out of the way, let's actually get started. So I'm here in a new folder, new Python environment. If we look at our pip list, we have nothing. So I've started out with a compute.slang, and if you notice, it looks basically exactly like HLSL, and a blank main.py. So today we're actually going to be using something called slang py, right? If we pull it up here. And this is the Python package for slang. So it lets us hot reload our shader code. It lets us run our compute shaders all from within our Python file. So we could compile with slang C, but you know me, I'm a Python sucker. I'm going to be using the slang py. And how do we actually get started with that? Well, I mean, you could just follow the website, but for those of you who don't want to, I'll show you a quick and easy way of doing it. So first thing is, obviously, as you saw, we want to pip install slang py. Alright, and once that's finished, we can come over to our Python and do import slang py as spy. And it's kind of important that you do it as spy. The whole API uses it as spy. Obviously, you don't have to. It's not really going to change anything, but for consistency's sake. So the first thing we want to do is create a variable called device and set it to spy.createDevice. And you could pass arguments in here if you want to, or you could just leave it empty, and it's just going to detect the GPU, and it's going to create a Python object of that. This is what everything's going to run off of. This is what you're gonna load your program onto, all that. So, like I said, the next thing we're gonna want to do is create a program, which is device.loadProgram. And you'll notice we have module name and entry points. So we're gonna define our module name as compute, and it default thinks it's a .slang. So if you want to write anything, it has to be a .slang at the end, as far as if you're doing it with this method, and it'll default think it's a .slang. So for example, all I had to pass here is compute. The next thing we do is we pass a list, and this is going to be a list of all of our entry points. So if we look at our compute slang, our entry points are defined by our shader compute attribute up here. So every entry point needs this, and it also needs to go in here. And because of that, we can name this literally whatever we want. We could name this anything. We can name it test, hello world, whatever you want. And the final thing we have to do is actually create a kernel for this. And that's going to be a device.createKernel. Well, compute kernel. And we pass our program. Alright, we're actually done. We could just do kernel.dispatch. Pass it a list of our threads. This is our dispatch threads. And if we run this, it'll run perfectly fine. Of course, it won't do anything, but that's more on our code than anything. So let's actually make it do something. Let's work with a buffer. So let's import numpy as np. This is going to be for our management of data. Let's create a buffer array and call it, we'll make it an np.zeros array of size 16. We'll give it a type of np.float32. Now we have to actually create the buffer object, and this is what goes to our shader. So let's create a buffer shader. Let's do device.createBuffer. And you'll notice we have a lot of arguments we could pass to it. So we have the size If we know the exact size and we just want to do it that way, it's perfectly fine. And I've actually done it that way before. It makes things easier. Or we could just do our element count. We set it to 16. We do struct size, which is the size in bytes of a single element in our array, which will just be 4 because it's MP float 32. We'll do our buffer usage. So we set usage equal to spy.buffer usage, and we want to write to it, so we do unordered access. And that's basically it. We've created our buffer. If we want to pass our data here, we could just do data equals buffer array. But if not, we can always do buffer shader, say copy from numpy, and then pass the array that way. All we have to do now is pass our vars as a dictionary, call it whatever we're going to call our read-write structured buffer, and set that equal to buffer shader. So now we've created our buffer here. Let's actually create the buffer in the shader. So if we go up all the way to the top, we could do rw structured buffer of floats and call that output. So our buffer name, like our variable name, and this have to match. Other than that, we could do whatever we want. So if we run this, it'll run perfectly fine, but obviously it won't do anything. So let's actually use the buffer. So I think I'm just going to make every index of the buffer have its own thread index. So let's say output thread id.x and just set it to thread id.x. And if we go over here, we just need to actually read out the buffer. So if we print buffer.shader.toNumpy, it in theory will give us what we want, but there's a big problem with this, which I'll explain in a minute after I just show this. So yeah, so we have a bunch of zeros. Okay, so what we want to notice here is we only ever call one thread or one work group which has one thread in it. So our thing, if we run it, will only ever evaluate to the first index, which of course the first index of that is 0. So if we just set this to the length of buffer array, that should do what we want, but there is also another problem. That's not right. So why is this happening? Well, if you notice, this is obviously not 16 elements. This is actually, if we were to print this and check it, it would be 64, because it thinks every byte is going to be its own U8 int. And the way to fix this is if we just do .view. So this will reinterpret the bytes in the format that we give it, which is the original format, MP float 32, and the format we're actually passing to it. Then we will get what we want, of zeros all the way up to 15. So a couple of important key notes here. If we're using buffers, we need to make sure we know our bytes. Like, you need to be pretty comfortable with bytes and how they relate to memory, memory types, all that stuff. You need to be pretty comfortable with NumPy, and if not, I mean, it's pretty easy to figure it out. But the important thing to remember here is you want to keep data consistency. Our toNumpy is not going to change the array for us, so we're going to have to reevaluate the bytes. It's kind of up to us to make sure the data stays consistent types and all that. So another important thing to note here is we're using this as a RW structured buffer as a global variable. And that's fine and all. Totally can do that if you want to. The other thing we can do is we could always just pass it as its own argument. And if we get rid of the semicolon, if we pass it as its own argument, we can actually just pass this as output equals buffer shader, and it'll do the exact same thing. So that is kind of an important thing to remember. If we want global variables, they have to be in that vars dictionary. If you want input variables, you just pass them as normal kwargs. The thing with this is it's super easy to kind of mess this up. And global variables kind of keep consistency throughout. So, you could pick or choose your battles here. The other thing you could do is you could always create a module of the function, and a module of the function will just allow you to basically dispatch the threads without like doing all this. So you don't even have to write the shader. You just write the shader function. You pass the things, you pass the variables, and it would run it on the GPU itself, which is another thing Slang PY does really well. And that's actually so simple. I'm not even gonna make a video on it. It's like 2 lines of code, and I mean you can check it out on the Slang PY API, which I will link in the description. But other than that, that's it. Have a good day.